Okay, guys, so let's warm up just kind of by doing what we've been doing with solubility. And so what we're going to do first is we are going to be looking at each chemical, and we're going to figure out the positive and negative ion that comes out of it, okay? So let's start with NaCl. So we're going to take a look at the solubility table. This is where we get the information. So if we have NaCl, what is one ion? What's one ion that comes out of NaCl? Yeah, Na, right? So Na plus 1. And what's the other one that comes out of it? Yeah, Cl minus, right? So underneath that chemical, we can just write Na plus and Cl minus. Super simple. So underneath this guy, let's write Na plus and Cl minus. So right now for this problem, no, but this will be very helpful in what we do today. Yeah, because at the end, today, what you're going to learn is how to write this backside. So the problems today will look like this, and you got to write the backside on your own. Yeah, so this will be kind of helpful for, I know it's a little bit of extra work right now, but just write that down for now. Okay. Yeah, good question though. Okay, so now we want to fill in the parentheses. And if you guys remember, for the parentheses, if something dissolves in water, if it's SOL, we write AQ in the parentheses. If something is insoluble, it does not dissolve in water, we write S because a solid forms. Okay, so if we take a look at our chart and look at NaCl and where they connect, does this dissolve in water? Yes. Yes, it dissolves in water. So in the parentheses, we're just going to write AQ, okay? All right, so far so good? Making sense? Hopefully it's not too bad. Okay, I'll do one more with you guys, and I'll have you try the other two on your own. But let's start with this one right here, AgF, okay? So if we take a look at the chart, what's the positive ion that comes out of AgF? Yeah, Ag plus 1. And then obviously the negative one is F minus. Okay, hopefully the grade you don't get in this class. Okay, so Ag plus and F minus. Okay, so far so good, guys? All right, so let's line it up on the table, see if it dissolves in water. So AgF, does this dissolve in water? Yeah, it does. It's soluble. So for the parentheses, we're going to write AQ, okay, because it is soluble. Alrighty, so I'm going to give you guys about 2 minutes. I want you to work with the person next to you and do the same thing for this guy. If you don't want to write this down, that's totally fine. Just see if you guys can fill in the parentheses. Does it dissolve in water, AQ, or not, S? So take about 2 minutes to fill that in, and then we'll go over it, make sure we're all good, and then we'll go on to the new material for today, okay? Take about 2 minutes to do that. Okay, so if we take a look at NaF, same thing, we can just line it up on the table. So we go to NaF, and does this one dissolve in water? Yeah, it does. It's soluble, right? NaF is soluble. So this dissolves in water. So we're going to write that this one is AQ. Let's move on to the next one, AgCl. We're going to look at Ag and Cl. Does this one dissolve in water? No, this one is insoluble, so it does not dissolve in water. So what we're going to do is we're going to write S to write that it's a solid. Okay. So if you got AQ, 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 S, then you did perfectly. Okay. Okay, so that's what we've been doing up. Oh, and then last thing, identify the precipitate. Precipitate is the solid that forms. So anything that has S next to it. So this chemical right here is the precipitate. Okay. So if you want to jot that down. Sorry about that. Totally forgot that question. All right, so that's what we've been doing up until this point. And then what we're going to do now is, like I said earlier, it's going to become a little bit trickier because I'm not going to be giving you guys this backside anymore. You're going to have to figure out if it's AQ or S, and you need to finish writing the entire equation on your own. So things are going to get a little bit trickier, but I'm going to give you guys some tips to make it a little bit easier for you guys, okay? Okay, so what I want you guys to do real quick is I want you guys to take about 30 seconds. I want you guys to copy down this equation, okay? This is the first problem that we're going to be doing today. We're going to take a step-by-step, make sure that we're all on the same page, and then we'll do one more example and we'll be all done. So just copy down that equation. I'm going to show you guys how to finish writing the right side of the equation, and then Yeah, so take about a minute to do that. Okay, so first thing we're gonna do, same thing as before, is we're going to first look at the positive and negative ions that come out of this. Okay, so let's take a look at the first one, CAS. Okay, what's the positive ion that comes out of CAS? Yeah, Ca, good. So we got Ca, and then obviously the other one is gonna be S, right? So if you look, Ca is positive 2, S is negative 2. So let's just jot that down right here, underneath the equation. So we got Ca 2 plus and S 2 minus. Okay. That makes sense how we got those ions? Okay. Let's go to the next one now. We got CuCl2. So we're going to take a look at CuCl2 on the chart. So if you guys look, I'll do this one for you. You got Cu 2 plus and you got Cl minus. Okay, so we're going to jot that down underneath as well. So Cu is going to be 2 plus and Cl is going to be minus. Okay, and just to make life a little bit easier for you guys, I'll just tell you guys that they're both aqueous. They both dissolve in water. Okay. Alrighty, so that part should be pretty easy. Basically what we've been doing. Now what we have to do, the new thing is we need to write the other side of the equation. We're basically figuring out if we mix these two chemicals, what chemicals are they going to make when they mix together, okay? So I want you guys to write this term down. Now, if you guys notice today, the lecture is called precipitation reactions. Another term that we can use is called double replacement. Okay, so write this word down because I think it's helpful in helping you guys remember what actually happens in these kinds of reactions. So this helps you solve the problem, double replacement. Okay, so you replace something 2 times. That's what you can think about. Okay, so these types of equations are called double replacements because something gets replaced twice. Okay. So what that means is you're going to take the positive of one of the chemicals and then you're going to combine it with the negative of the other. Basically, they're switching the positive and negative with each other. So you're going to combine them together. So you're going to get Ca and you're going to get Cl. And those two are the ions that are going to combine now. They're going to switch. They're going to replace. Okay. Now, before we finish up the formula, we need to make sure the positive and negative energy balances out, right? So if Ca is +2 and Cl is -1, it's obviously not balanced, right? Do we have too much positive energy or negative energy? Yeah, we got way too much positive energy. How many Cls do I need to balance out the positive energy? 2. Yeah, so we just put a 2 behind the Cl, and that's it. Okay, so that's the first one. Okay, but it's a double replacement, so we have to do that twice. So we're going to take the positive of the other one, and we're going to combine it with the negative of this one. And so they're going to combine to form Cu and S. Okay, so if you guys notice, we just basically switched the positive and negative. Now, if you guys take a look at this, does the positive and negative energy balance out? Yes, so we can just leave that alone and we're good to go. Okay, and I'll make your life easier since it seems like you guys got this down. This one is going to be aqueous. This one is going to be a solid. Okay. So we'll skip that one just because it seems like you guys have a good handle on the aqueous and solid stuff. Alrighty, there is one last thing that we need to do because if you take a look at the instructions, it says to complete and balance the equation. So we did the completing part. We wrote the other side. Now we need to balance the equation. Does that sound familiar? You guys remember balancing equations? We did that back in like October, November, maybe. Oh, well. Well, now we got to balance. So I'm going to erase this part right here, and I'm going to show you guys how to balance an equation. Basically, what it means is you want to have the same number of elements on the left side and on the right side. Okay, so what we're going to do is we're just going to figure out what's on the left and the right. Okay, so elements are very easy to figure out. It's the same thing as the ions. So first we have a Ca, we have S, we have Cu, and we have Cl, right? Those are the 4 ions that we were working with. And what we're going to do is we're going to put them on a table like this. And all we're going to do is we're going to count how many we have on the left side of the arrow and the right side of the arrow. So hopefully that's kind of clicking now. We did this a while ago, but we have done it. What's up? Yeah, just sign out and take the pass. Okay. So I'm going to count the ones on the left side with you guys, and then I'll have you guys try the right one on your own just to get some practice, but I'll give you guys a couple seconds to copy this down. And it's called balancing. So we want to make sure the same number of everything is on both sides of the arrow, okay? So let's take a look at the left side of the arrow, okay? If you guys take a look at CA, how many times or how many CAs do you see on the left side of the arrow? Just one, right? Okay, just one. If there's no number behind it, it's one. How many S's are on the left side of the arrow? One, good. How many CUs are on the left side of the arrow? One. And how many CLs are on the left side of the arrow? Two. Yeah, the number behind applies to only the guy right in front. So it's going to be two. Okay. All right. So I'll give you guys about a minute to fill out the right side. I want you guys to figure out how many of everything's on the right side. And then we'll finish up the problem from there. Take a minute to count up the guys on the right side. Okay. So if we take a look at CA, how many CAs do we have on the right side of the arrow? One. Good. It's just one right here. How many? Let's go to the next one. CLs are on the right side of the arrow. Two. Yeah, there's a two behind it, so it's going to be two. Okay, how many CUs? One. How many S's? Okay, so is this balanced? Yeah, everything's the same number, so we're good to go. This is a perfect equation. We're all done. Okay, now the first one that we did together is easy. The next one, you will have to do some additional steps, but I just wanted you guys to get into the practice of counting the elements. Any questions on the counting? Okay, all right, let's answer the last part of the question. It's very easy. Identify the precipitates. Precipitates are just the solids that form, and there's only one solid, so this guy right here, CUS, is going to be the precipitate. Okay, what's up? Yes. So take about 2 minutes, and I want you guys to just start by figuring out the positive and negative ions that come out of these two chemicals, okay? So same thing that we've been doing. What's the positive one that comes out? Negative one. And if you have some time and you want to try doing what we did today, finishing the equation, please feel free to do that. But at least for the next 2 minutes, try to figure out the positive and negative ones that come out of these two chemicals, okay? So take about 2 minutes to do that, and then we will just make sure we're all good. Oh. Okay, guys. So hopefully you guys were able to see that for the first chemical, the positive ion is NH4+. And you can see that right here. It's the first one right here, NH4+, okay? I know that one's a little tricky because there's a 4 and all these numbers, but it's NH4+. The second one is SO4 2-, and it's right here, okay? SO4 2-. Okay, now again, you want to make sure you copy things down exactly the way they're written. Make sure you don't forget the 4. Make sure you don't forget, yeah, the 4s and the letters. Make sure they're capitalized. Copy it down exactly the way they are, okay? All right, for the second one, pretty simple. It's Li+, a little bit easier to write than the other ones, and then Cl-. Okay, and all those things come from this chart right here. Does anyone have any questions on how we got those ions? You guys good? Okay. All right, now we're going to do the double replacement. So we're going to finish up the other side. So we're going to take the positive of one of them, so this one right here, and we're going to combine it with the negative of the other one right here. So we just put them first right next to each other, NH4 and Cl. Okay, now if we look at the positive and the negative energies, +1 and -1, so are they balanced out? Yes, so that one's good to go. And seems like you guys, again, have a good understanding of the aqueous solid stuff, so this one's aqueous. Okay. All right, let's go to the other one now. So we're going to take the positive of this one and the negative of this one, and we're going to put them together. So we got Li and we got SO4. Okay, now if we take a look at this, we got +1 and -2, right? So obviously not balanced. Which one do we need more of, Li or SO4? Yeah, Li. How many Li's do I need in total? 2. So since we need 2 of this, we're going to put a 2 behind Li just to make sure that the energy balances out, okay? And this one is also aqueous, Okay, so if you guys understand that, then good job. That's pretty much what we'll be doing going forward. All we need to do now is balance the equation. Okay. All right. Yes.
Does it matter if SO is like grid?
Yeah, good question. So it doesn't matter. You could put SO. So if you wanted to write it like this, SO4 Li2, that works as well. I just recommend doing the positive one first because when you do the naming, you know how we name it positive and then negative, it might be more helpful if we do it like this. But if you keep track of it, this is fine too. Yeah, good question. Any other questions? Okay, let's do the balancing to make sure that we have the same number on both sides. I'll let you guys know already we don't. So let's do the balancing and then we will move on to finish up the problem, okay? So what we're gonna do is we're gonna write down the ions that come out of this. So we said the first ion was NH4. We said the next one was SO4, and then Li and Cl. Everyone good on why we're putting this on the table, right? This is the ions that we pulled out. And what we're going to do is we're going to count how many of each we have on both sides. Okay. I'll give you a second to copy down that table, and then we'll count them together. Okay, guys, let's count them up together. So if you take a look on the left side, how many NH4s do you see on the left side of the arrow? 2, yeah. I know it's tempting to say 4 because, hey, there's a 4 here, but remember, we're counting the 4. Okay, NH4. How many NH4s? There's a 2 on the outside of the parentheses, so there are 2 NH4s. Okay, everybody see that? Okay, let's take a look at the next one. How many SO4s are on the left side of the arrow? 1. Yeah, I know it's, again, tempting to say 4 because there's a 4, but we're counting the 4 inside SO4, so you only see it written 1 time. So we're going to write 1 for SO4. So yeah, I know the numbers get really confusing. That's why it's really important that you guys understand how to copy things down correctly and you don't forget and skip stuff by accident, okay? Okay, the next one's pretty easy. How many LIs? 1. How many CLs? Good, easy peasy. All right, let's go to the right side now. I'll help you guys out with this. There's going to be 1 NH4. Okay, got it right there. You got 1 Cl, so we're going to write 1 Cl. We have 2 LIs, and we have 1 SO4. Okay. All right, now if you guys notice, this is not balanced this time, right? You got more NH4s on the left side, and you have more LIs on the right side. And so we need to balance out the equation now. Okay, so let's start with NH4. You always want to add to the side that has less. So we're going to add to the right side, okay? Because it has fewer. Okay, now the thing about balancing is you can't just add what you need and go. You can't just add that because then you're changing what's happening inside the reaction, right? And so we have to add the entire molecule written exactly the way it is. Okay, we need to copy down the whole thing. Okay, so if we take a look on the right side now, how many NH4s do you see on the right side? 2. You got 2 like this. But we also changed the CL, right? Because we added more CLs. How many CLs are on the right side now?
2.
2, yeah. So we changed the NH4 and we changed the CL. Okay, so we got 2. So this one's balanced. It's good to go. This one's balanced. But now these 2 are both messed up. Okay, you guys all see that? Okay, so now we need to add Li and Cl to the left side. Lucky for us, we have a chemical that's just LiCl, right? So we're going to write LiCl. And now we have 2 Li's and 2 Cl's, and we're all balanced and good to go. So everybody is balanced now. Does that make sense? Yeah. That's basically the new, I guess, hard thing that we are doing today. And you'll have the entirety of next week to practice this. And I'll leave the answer key with the sub so you can always check your answers. Yeah, and I'll be on Canvas when I'm on my breaks at jury duty, so you guys can always message me and I'll try to help you guys out if I can. Okay. Okay, of course. So one last thing, we just need to put numbers in front of the chemical. So I'm going to erase this just so it's easier to look at. And again, this is all recorded, so you guys can always go back on Canvas and take a look at the video if you missed something. So what we got to do now is we need to put numbers in front of these chemicals, okay? So if you take a look at this, we only have one of this chemical, so we can leave it alone. How many times do we write LiCl inside this in right here?
2.
2. So we put a 2 right here, okay, to represent that we wrote it 2 times. How many times do we write NH4Cl? 2. Yeah, there's 2 of them, so we write a 2 in the front. And then this last one right here, we only needed one of them, so we can leave it. And so this right here is what your final answer should look like. It should look pretty much exactly like that. Okay. Okay, so let's do the picture and the precipitate and we'll be all done. But this is same stuff we've been doing. I'll go through this part really fast. You guys don't need to copy this down in your notes because you guys already have notes on the picture and the precipitates. But on the left side, we're just representing what's on the left side of the arrow. If something is AQ, it breaks apart in water. So we just write down the ions that it breaks down into. So this breaks down to NH4 plus, SO4 2 minus. We wrote that down earlier. And this chemical breaks down to Li plus and Cl minus. Okay. Hopefully that's familiar from what we've been doing. On the right side, this chemical is aqueous, so it breaks down into NH4 plus and Cl minus. This chemical breaks down into Li plus and SO4 2 minus. And if you notice, everything is AQ. So the answer for C is that there are no precipitates. Okay, so if you want to write NP just for short, you can do that as well. All right, and that's pretty much it. That's all the new information that we'll cover today. I know we went through it a little bit slowly. I just wanted to make sure you guys had time to sit on it. God bless you. So I will give you guys the rest of the class period to work on this assignment. If you have any questions, please let me know. Again, I got answer keys as usual if you want to check. And yeah, give you the rest of the class period to finish up today's assignment. All right, good luck, guys.